Have you ever wondered how to learn Python effectively? In the digital age where coding is as essential as reading and writing, Python emerges as a key player. It is a simple, versatile, and highly sought-after programming language in various industries, from tech to finance to research and beyond. Today we're going to introduce you to a roadmap for learning Python, a journey that is far from intimidating but rather exciting and rewarding. Python's importance cannot be overstated. It is the backbone of many applications and systems we interact with daily. Websites, games, data analysis tools, artificial intelligence models, Python's footprint is everywhere. Why? Its simplicity and readability make it an ideal first language for beginners, while its powerful libraries and frameworks are valuable tools for experienced developers. But how do you start learning Python? It begins with a roadmap, a clear step-by-step guide that breaks down the learning process into manageable chunks. This roadmap is not a rigid path, but a flexible guide that you can adapt to your own pace and learning style. First and foremost, this roadmap emphasizes understanding Python's core principles and syntax. It's like learning the grammar and vocabulary of a new language. You'll learn how to write and execute Python code, use variables, loops, and conditionals, and handle data types and structures. As you become comfortable with the basics, the roadmap will guide you through more advanced concepts. You'll explore Python libraries and frameworks, delve into object-oriented programming, and learn about error handling and debugging. Along the way, you'll get hands-on experience with projects that challenge you to apply what you've learned. But the learning doesn't stop there. The roadmap encourages continuous practice and learning, whether through online courses, coding challenges, or personal projects. Remember, learning Python is not a race, but a journey of discovery and growth. Embarking on a Python learning journey doesn't have to be daunting, and with the right roadmap, it's a breeze. Embrace the journey, enjoy every step, and look forward to the opportunities that Python can open for you. Let's dive in. The first step on this journey is setting up your Python environment. Think of it as your digital workspace, where you'll write, test, and debug your code. It's essential to have a good Python environment to make your coding experience smooth and efficient. Now, there are three primary tools that you'll need: a Python interpreter, an integrated development environment or IDE, and a text editor. The Python interpreter executes your code, while the IDE is a software suite where you'll write and debug your code. The text editor is where you'll write your code before it's executed in the Python interpreter. There are many options available, but some popular ones are PyCharm for the IDE, Jupyter Notebook as a Python interpreter, and Sublime Text for the text editor. Each tool has its strengths, so find what works best for you. With your Python environment all set, you're ready to dive into coding. Now it's time to get familiar with Python syntax and basic concepts. Understanding Python syntax is like learning the rules of a new board game. It's essential for effective play, or in this case, efficient coding. Python syntax is clean and intuitive, making it a great language for beginners. But don't let its simplicity fool you. Python is a powerful tool used by professionals in diverse fields, from data science to web development. Let's start with variables. Variables are like containers that store data. In Python, you don't need to specify the type of data a variable will hold, unlike in some other programming languages. You can simply declare a variable like this: my_variable =, hello Python. Now let's jump to data types. Python has several data types, including integers, floating point numbers, strings, and booleans, among others. The type of data a variable holds can impact how Python interprets your code, so it's important to understand these basic data types. Next up are operators. Python uses operators to perform operations on variables and values. For example, the plus operator can be used to add two numbers, or concatenate two strings. Then, we have control flow statements. These are the decision-making elements in your code. They guide the execution of your program, depending on whether certain conditions are met. If, else, and elif are some of the control flow statements in Python. Finally, we have loops. Loops are used to execute a block of code repeatedly until a certain condition is met. Python supports two types of loops: for and while. Understanding these basic concepts is like learning the alphabet before writing sentences. It's the foundation upon which more complex concepts are built. So, take your time, practice, and don't rush the process. Remember, even the most seasoned coders once started where you are now. Mastering these basics is a crucial step in your Python learning journey. Next on the roadmap is learning about Python functions and modules. Imagine you're a chef preparing a complex meal. You wouldn't chop vegetables every time you need them in a dish, right? You'd chop them once and use them throughout your cooking. That's the idea behind Python functions. They are like pre-chopped veggies, bits of code you can call upon whenever you need them, making your code cleaner, simpler, and more reusable. A function is defined using the def keyword, followed by the function's name and parentheses. Inside these parentheses you can include parameters, which are like the ingredients in your recipe. The instructions or the recipe goes within the function's body, enclosed in curly braces. Once you've defined your function, you can call it by its name as many times as you need, just like reaching for those pre-chopped veggies. Now let's talk about Python modules. If functions are pre-chopped veggies, then modules are like your kitchen drawers, each containing related tools or utensils. In Python, a module is a file containing related functions and variables. It helps us organize our code in a logical and manageable way. Some of the most commonly used Python modules are math, datetime, and O's. The math module, as the name suggests, provides mathematical functions. Need to calculate the square root or sine of a number? Math is your go-to module. The datetime module helps you deal with dates and times. Want to know the current date or calculate the difference between two dates? Datetime has got you covered. The O's module provides a way of using operating system-dependent functionality. Want to change the current working directory or get the user's environment variables? O's makes it possible. Just like a well-organized kitchen enables a chef to cook efficiently, mastering Python functions and modules will make your coding journey more effective and enjoyable. Understanding functions and modules will take your Python skills to the next level. Moving forward, it's time to delve into advanced Python concepts. First, let's tackle object-oriented programming, more commonly known as OOP. OOP is a paradigm that provides a means of structuring programs so that properties and behaviors are bundled into individual objects. In Python, everything is an object. By understanding OOP, you can write more organized and reusable code. Now, let's shift gears and discuss error handling. Even the most experienced programmers make mistakes, and that's where error handling comes in. Python uses something called exceptions to manage errors. When an error occurs, an exception is raised, and you can use try and except blocks to catch and handle these exceptions. This allows your program to continue running even when something unexpected happens. Next, let's talk about file input-output operations, often referred to as file I/O. File I/O allows your program to interact with files on your computer. You can read from files, write to files, and even create new ones. This is incredibly useful, as it allows your Python applications to work with data in a persistent way. But what makes these concepts truly advanced? It's because they allow for the creation of more complex and robust Python applications. By mastering object-oriented programming, you can create classes and objects that encapsulate both data and functionality. With proper error handling, your programs become more reliable and resilient. And with File I/O, your applications can store and retrieve data, enabling them to interact with the world outside the confines of memory. These aren't just tools or techniques. These are powerful concepts that will transform the way you think about programming. They'll help you see beyond lines of code and understand the bigger picture. They'll enable you to design and build applications that are not just functional, but also reliable, scalable, and efficient. These advanced concepts are your gateway to creating sophisticated Python applications. Lastly, remember that practice makes perfect. Delving into the world of Python, or any programming language for that matter, is like learning to play an instrument. You won't master it overnight. It requires consistent practice and dedication. So, how do you practice coding? A great way to sharpen your Python skills is by working on projects. Projects provide a practical context and help you understand how the concepts you've learned fit together. Whether it's a simple calculator or a complex web scraper, every project adds to your learning journey. Contributing to open-source projects is another fantastic way to gain hands-on experience. It exposes you to different coding styles and techniques, and helps you understand real-world applications of Python. Additionally, consider solving problems on coding platforms. These platforms offer a plethora of problems, ranging from easy to hard, that challenge your understanding of the language. With consistent practice and projects, you'll soon become proficient in Python.